Welcome to EDU World Space.
Okay, so we're in chapter 32, problem 30. So this says an object is placed at a distance r in front of a wall. So here will be our object, so distance r. So where r is exactly equals the radius of curvature of a certain concave mirror. So at what distance from the wall should this mirror be placed so that a real image of the object is formed on the wall? And what is the magnification of the image? So somewhere over here, we're going to have a mirror. And this is going to be our object distance. And we want the image exactly on the wall. So our total image distance is given as this. Cool. So we can also relate now our object distance is going to be the image distance minus r from this. So using this, we can go to our mirror equation now. So we have 1 over the focal length, which is also 2 over r for this mirror. And this is equal to 1 over the image distance plus 1 over the object distance, but we can put that in there for that. So this is di minus r. Cool. So now let's go ahead and simplify this by multiplying everything by r plus r over di minus r. Now we can multiply everything by di. Cool. And now we can multiply everything by that, and we should be left with 2r di squared minus 2r squared di equals r di minus r squared plus r di. If we simplify this, we should see 2 di squared minus 4 di r plus r squared equals 0. So we want to solve for the image distance di here, and this is a quadratic equation, so we can use the quadratic formula. So let's go over here, say di equals, the quadratic formula for this equation is 4r plus or minus square root 16r squared minus 8r squared, all over 4. Cool. So we can simplify this pretty easily here, and we'll be left with 4r plus or minus 4r square root of 1 minus 1/2 over 4. If you simplify that, this is r times 1 plus or minus square root of 2 over 2. Cool. So let's plug that in. This will give us 2 answers because it's a quadratic equation, and we should be left with 0.292r and 1.71r. So we know the image or the mirror has to be placed on this other side of the object, so it's going to be greater than 1r, so it's got to be this one. So exactly, we want di to be 1.71r. Cool. So now let's use the magnification equation to find what this is. 1 over di over d naught. This is 1.71r over 1.71r minus r. And that's negative 2.41. Awesome.